Hello, good day, everyone. Welcome in today's topic, Big Data, Big Risk. I will take you today in a journey to navigate the complexity of securing big data in the cloud. I'm with you, Fuad Mullah. I'm a cloud security architect and lead consultant. My main focus is cloud security and enterprise applications in the essence of big data. This is a little disclaimer. Just I'll give it a little bit on the screen. Just basically, this perspectives and opinions is all exclusively mine and does not represent the associated organization of mine. So I'll give it for a few seconds and then I'll go ahead. Okay, let's go. So I would like to start with this. Says, "In God we trust; all others must bring data." It's for me just really illustrate the essence and the value of big data. Generally, obviously, in business application and all the aspects of daily life, we need people to bring us evidences. We want people to bring us statistics, proof that the idea can work, and this is the essence of big data. So without big data, there is in the old time was we were trying to, as much as we can, to imitate the essence and the nature of big data. With the increase of usage of now the data production and the usage of the big data system and the value created, it's affected us and it's affected our understanding and the application of business intelligence and its security by organizations. Security now is significant concerns this day, actually independent of the field and technology, but today's focus on big data. Like you with the agenda, basically we'll start with introduction and a couple of big data incidents, understanding the big data, a little of background, risk and challenges, and addressing these challenges and lowering the risk. I will also touch a little bit as a bonus on the latest trend on big data security. So, how many of you using big data now in your daily life, in your daily interactions? Okay, maybe you're not aware, maybe you are aware, but you are using probably Google Maps. You're using Google. You're using Netflix, Amazon. You are purchasing using eBay. You are sharing on social media. All this kind of application. The essence of it is big data. It's visualizing all the text, all the comments, all the user behavior, all the video we share, the audio we share, to analyze these and give us right away analytics and also taking decisions to what we have to see next, to what we have to purchase, suggest us a couple of items, and ingesting and processing this data in the background. So big data, obviously, it's already essential part of our daily lives. And we rely on the communication and consuming this data and the real-time analytics to perform our daily activities. This is just a little let's say, joke on arrival that your recent Amazon purchases, tweets and tweet scores and maybe now X scores and location history makes you 20% welcome here. Well, this is obviously represent the implications of big data as well on the privacy level. So this is just the beginning. So what does it mean? 175 zettabytes. It's the global data sphere that will grow from 33 to 175 by 2025. So I'll try to present you what is coming by the upcoming, let's say, 3 years scape. IoT devices is expected to produce over 90 zettabytes by 2025 alone. So what does it mean? Just for your relate the amount of data, 1 zettabyte is around 1 billion terabyte. So you can imagine, and if you stack this, if you produce DVDs and you store all this data on DVDs, it will stretch from the Earth to the Moon around 36 times. So this is the scale of the data we are producing and we are processing in the upcoming years. 50% of this data ingested will reside in the public clouds. as this will be the new core or new home for these data. 30% of these will need real-time processing. So whether it's social media, whether it's your favorite purchasing app or banking system, all this has to be processed immediately and presenting you with real-time interactions. So we can see the scope is really wide and the usage is increasing. So here's a little chart I'd like to share with you. It's a little bit old, but it's presenting the boom of the big data we are. So we can see that there's expansion of sensors and devices, as well as on social media production of data, as well as on the enterprise application. We are just in the start, and this boom will continue to grow. So this presenting us with a lot of concerns, a lot of considerations to be taken as part of this dilemma or these challenges. What application? Just to give some context also on the wider level. So critical infrastructure protection. The more we are using the IT infrastructure, the IoT infrastructure, and it's playing a vital role in our daily more critical infrastructure. It's being part of it, and protecting this is essential for nationwide security. As well as the edge computing evolution. Now the more sensing layer is being grown. Edge computing is becoming also essential, allowing real-time processing and redundancy, ensuring efficient time on the bandwidths as well. This is with the presence of 5G at the moment and even 6G coming soon. Let's understand also the market forecast. We can see that the global IoT market forecast is being growing. So it's actually not growing, but booming in essence. So in a growth of 23 to 16% in the upcoming few years. This is in essence of the wireless neighborhood area, so the wireless networking, as well as the wired IoT and 5G IoT devices. So all my charts today is just going up, as you can see. So the volume, the data, the market, there is no doubt that the big data is booming, and we are actually in the let's say in the middle of this era. The more we present with the value of the big data and the scale of big data, this has come up with big risk. Big challenges, and as well as big opportunities and value, as I just demonstrated. So let's tackle a couple of incidents that presented us with the current or the latest issues that we have. In essence, actually, just to touch a bit, big data security missions is very much similar to many of our application security or the enterprise security, let's say, network security. Well, essence is protecting an unauthorized user from accessing this data. So having firewalls, having strong authentication, end user training, IDS, IPS, all these kind of things is pretty much similar to any typical protection. However, when we say, let's say, enterprise application or network security, it's pretty much understood or understandable. But when it comes to big data environments, is the level of complexity and the essence of the volatility of the data and the systems can present us with much more challenges. So let's see the effect of this kind of incidents. Well, I don't know if you've heard, but this is from The Guardian, the biggest hack in history. Australians scrambled to change passports and driver license after Optus Teleco data debacle. So this was a big incident where a couple of Australian data breach happened on the personal information level, and this was caused affected 3 million individuals that has their essential identification being accessed. Optus is telecommunication that doing sometimes some of some registration, taking personal data to initiate contracts and such. However, there was issues that this company is retaining data which not anymore used. So this widened the scope of the exposed data to further to more Australian people. This was concerns to the government when the Optus hack was declared, and all the Australians has to renew or change passport, changing driver license. So it's really affected the whole country. So it's a nation country wide security issue. So we can relate and we can understand how this can be a big deal. Another little example is from LinkedIn, where this is back to June 21, where impacted 700 million users. So it's basically one person exposed the API vulnerability to extract and scrap all information of users on the platform. And as we know, LinkedIn has a very much quite public data, but at the same time, it's really valuable when correlated and when collected by an authorized person. And this was over 700 million users. So you can imagine the social engineering techniques that can follow up using this data, especially that it's a business-related information. So this is a couple of the incidents. Of course, there is many, but I try to keep it to this level. Let's understand the background of big data as well, so we can tackle this a little bit more in depth. So probably, obviously, many of you relate that many applications now use the term big data. However, the essence of big data is more, I believe, or I identify as the technology being used and the 5 V's, which we will touch about in a couple of seconds. So big data is encounter of 3 main components, in my opinion. First, data, and data can be data which is stored, data in transit, processed, the visualization and the analytics behind of this data. So there's 3 categories of data. There's as well the systems. And here to identify big data systems, usually it's a quite complex system that involve batch processing as well as a hot path for streaming and for storage mechanism, which is high availability or highly distributed storage systems. Finally, the people. This is also a kind of component of big data, that the impact or the usage of big data usually it's from a wide range of people, not only the users but also the consumers. So this can add to the complexity of big data architecture. So what is big data and the inherited nature? So from the essence of big data, we can understand this variety and velocity and versatility and volume and value. It's all combined to compose the big data technology. So when it comes to value, obviously, once there is a lot of data, there is a lot of value. We can see now lately, just with the AI, that how this big data being used to extract more meaningful interactions with the human, with large language models, as well as the velocity. So usually the big data has a very much speed of changes. Versatility as well, the range of the inconsistency or uncertainty or reliability of the data, as well as the variety. This is the wide range of text, videos, audio, human interactions, everything, and the volume, which is usually quite a big amount of data stored and processed. Well, this can be expanded actually to more V's if you want. So vulnerabilities, volatility, validity, variability. So it can run to many other topics, but probably what our concerns today is vulnerabilities and threats. So let's touch on this as well with basically the weakest point in our systems, the people and users. Here we are presented with significant insider threat. So when you have all this data correlated and being stored in one place most of the time, it can reflect to more interest from insider to process or to utilize the data for their own interests. So this has a big consideration. There is also the unintended data sharing, which means that the users of the systems might share the data unintentionally or without thinking about it. So this is also one consideration, and also social engineering, since it's being used quite widely and actually it's applicable quite much in the big data scenarios, that you find the weakest point with one of the people has access to these and exploit everything inside. So there's a lot of issues that we can identify, like overprivileged access. But this is what I think it's the main issues that encounter everything from people side. Let's touch also on the systems, on the big data systems and the layers that is involved. There's usually a couple of components, let's say, that combine together to create the layers of the big data. From data sources, this is where you ingest or you get all the sources of data, from text, from video, from audio, from whatever you identify, and then you have the ingestion layer where you extract everything here. And then it comes to the either like patch processing, where it's like Hadoop management layer, or the storage layer, and warehousing, and doing the analytics on this data. There's good to mention, obviously, MapReduce as a main component on these usually architectures and systems. It's either for storaging, there is NoSQL databases, or HDFS, highly distributed storage systems. And there is on top of this all the visualization layer, and the base for this is monitoring and security. This is a bit of simplified kind of architecture, but this is a good to keep in mind what we have in the systems. This is if we tackle it in more pragmatic way. So we have the data sources, the data collection, query processing, storage, visualization, analytics, and security and monitoring. Good. So this is with a kind of understanding of the systems which we have. Let's take it to the paths or the ways that this data is being going through the systems. So obviously, if it's stored or if it's after ingested, it's stored and in the sources, either stored or in the sources. So it's coming to the storage after that, or the real time or right away processing. So this is if it's batched or streamed. And this is where happen the results and all the analytics. And finally, the endpoints and applications where you visualize, you have a self-service, you have a machine learning tools or whatever. Usually, just to mention that the key element here, that the fast data insertion, that can be a vast amount of data generated every second and stored and analyzed and reflected back to the user. There's distributed redundant data storage that it has to be in a special system, distributed file system. There's a parallel task processing that has to come through. Different type of data that is coming. It's a scalable storage or scalable system as well. And there's a large analytics and fast data insertion. So these are the main components. When we are speaking of big data system, it's good to mention now that since our topic is in cloud security of big data. Lately, there's the trend, obviously, to utilize as much as possible with cloud resources. So the traditional systems seems to have a limitation, obviously, for many reasons. And as we see, for example, with Hadoop version 1 and then Hadoop version 2 is main component of big data that is being a couple of issues being resolved, but still probably version 3 will be the cloud provider as a component in processing big data. So for example, also on the cloud level, many times we seen, I mean, from my work experience, is becoming kind of a key element to migrate whatever systems in different ways, in different levels, to cloud and utilize the power of the cloud. Let's touch on let's say a couple of migration options. This is what I just it's a good understanding, so we can know which level or which type of migration we are in. This is, let's say, a typical on-premise setup that used for big data, which contain the data sources, the hot bath, which is Kafka or Storm, and the cold bath, which is data lakes. We're storing with using HDFS, Spark, or Hadoop, Apache, and secured and all monitored by Ranger or by Ampere, and this all being reflected back to the users using some gateway or some app interface, whatever applicable. What options do we have? Well, there's a couple of options that can be presented for us. There's the lift and shift IaaS, which is utilizing the infrastructure only and just hosting everything on the cloud, so no modification, no changes. It's basically just rehosting and reconfiguration of the infrastructure on the cloud. There's lift and shift, but I'm here just suggesting the Azure technology, but can be applicable for any other cloud provider, which here we're utilizing HD Insights. So it's kind of a mixed approach or a hybrid approach. And obviously there's the last option, which is completely PaaS, which using all the components available on the cloud level that you could utilize. And here in this case could be the Cosmos DB, Apache Spark on Synapse, and Azure Databricks. So this is the 3 examples. So obviously just the last one will need much work, replatforming and refactoring or re-architecting the whole application, whether the other one more like infrastructure as a service, where you just minimum changes but utilize the power of the technology in the cloud. This is giving here a little of example of migrated application back to the cloud, so we can see the components that I'm using here. Obviously, that's present the power and the essence why migration that makes sense for the current time. A lot of functions, a lot of services being introduced, and it's powerful to cope actually with the essence of big data, because as just mentioned a couple of times, big data, real-time processing, all needs resources, which might be really handy in the cloud, while in the on-premise might be a kind of challenging to expand, to maintain, to keep all the pace and the latency on a certain level. So a couple of components here we can see from Azure. For example, we can utilize the Data Factory, the Azure Passion for securing the endpoints, the analytics, and a couple of other services for transformation, Spark on the cloud, Spark Pool, and also for visualization can be any third party like Power BI or Tableau, and for analysis services or Synbase on demand. Obviously, there's a couple of security and monitoring tools that is powerful and we can utilize that, such as the Azure KMS or Key Vault, the security groups, Defender on cloud, Azure monitoring, and Active Directory for securing users' authentication and authorization, as well as the couple of dashboards and such and analytics and monitoring tools that can be utilized in such a scenario. So good. Here now we understand now what is the essence when we migrated to cloud, so we can get to know what is risks, what is the challenges, and how we can improve this a little bit further. So what type of risk that we can encounter if you think about it from the all inherited from the nature of the big data. First of all, data breaches and unauthorized access. As mentioned, this is probably applicable to everything, but it matters the most in big data systems. We have to take into consideration that the breaches here might encounter us or challenge us with a lot of issues from compliance, from even decommissioning the whole company because of that. So it's really critical to keep unauthorized access of such a big data, especially when it's all correlated is in one place. It's such a security challenge. In other also terminology or in consideration that since the cloud architecture is usually exposed in different way than the on-premise, where we have our own networking system and our own premises. In the cloud, the consideration should be different, more around identity and access management, as well as the network security. But identity and access management can become a little bit higher in the importance of this such a case. Another consideration of security challenge is the incomplete data deletion. It's pretty challenging in the clouds because it's kind of part of the misconfiguration that it's quite famous. This is where it happened that the data is supposed to be deleted and not retained because of compliance, but at the same time in the configuration, usually a lot of time the data is preventing the deletion of data to quite extensive limit. Then it's on premise. So this has to be taken into account when assigning data retention policy and the unforgotten, let's say, configuration that ignoring some data being stored somewhere and not looked at. Third, compliance and legal risk. So coming together with all of these, as I mentioned, personal identified information all aggregated in one place, it can give more context than, let's say, and this is like a typical thing that when you ask somebody who's working in a certain company, well, do you store any critical information? Do you store any personal identified information? Do you store any credit card data? They are sure that they are not storing all of these. But at the same time, for example, when it comes to GDPR, which is a law that has at least and can hurt the company, it comes back to even to only names and emails when it's all aggregated in one place with phone number and address location. So all come together and complete this puzzle and make a compliance issue. So it has to be taken into account. Data sovereignty and redundancy. The data is usually in the cloud has a good or strong redundancy that is distributed, but at the same time it has to be coming back to compliance that in case the data is being stored in the places where it shouldn't be or processed in an area or in a region that it shouldn't be, that has to be taken into account. So this all has to be studied. Also taking into account data in transit or in rest. That if it's processed, where it's processed, the location, the way, if it's vulnerable to interception or any kind of unauthorized access. This can add a little bit for encryption overhead and authentication and access control being more formalized or more taken into account. There's also the complexity of big data cloud environment. So when it comes to provisioning new services, especially that the cloud services is really evolving and changing time to time. There's every day new service being added, so it can add a certain level of complexity to the architecture, which mean extra vulnerabilities. Good. Now that we touched on the data security, let's touch a bit on the privacy challenges. So aggregation, profiling, and handling, has to be taken into account. Storage and sharing protocol, what storage we are using. There's a lot of services, has to be evaluated. Does it fit with our architecture? The sharing protocol, is it compliant? Also the ethical and misuse that can be encountered whenever we are dealing with big data. This is a bit of chart took from a research, actually from Analytica, I believe. It's not written on the slide, but yeah, this is the challenges of big data as being surveyed in three majors, in the finance and the energy, power, utility, and telecommunication. You can see the access control is the first one coming in place, securing data management and validation and filtering, and fourth, application security. So we can see that these topics is the hot topics for challenges in big data in all these major sectors. So how to address these challenges? How to lower the risk? There's a couple of techniques and recommendations that we can use usually to do this. Obviously, taking the challenges and trying to resolve it in a systematical way. So, obviously, for simplifying the architecture and services technology as much as possible. Whenever we are using multi-tenant nature of cloud, wherever there's different type of services, new services being introduced on a regular basis, we have to kind of limit or protocol this to make it more consistent with our approach, and also to take into account all the vulnerabilities or risks that we are taking. So simplifying this architecture, it makes sense. When introducing a new service, making a survey, understanding the configuration, providing maybe training to the users, and consider all the risks in introducing such a new service. Second is a deep assessment when implementing a new cloud service, just what I touched on. So this is kind of comes together with the simplification of architecture. And third, build your strategy. This is, I always repeat, and it's really key component of many, let's say, migration project or new introduction to cloud. Or even if you don't have one and you are already in the cloud, you have to think about it. Strategy comes from the beginning of the migration process till the exit even. So in case you didn't fit into the cloud system for some reason, for a certain reason, that you have some strategy to exit. Also comes with a way or protocol, how you introduce new services, how you analyze, how you think about the provider. If there's any lock that you might encounter in the future, all this has to be taken into account. So strategy is a key component in addressing these security challenges. Obviously, raise organizational awareness. That can be a good investment in the future. Also enhancing your team or cloud professionals on security topics. That can be a good value in the future. Okay, I'll touch on each topic. Kind of I divided to a couple of topics that can be helpful to put our minds around specific components like access control and authentication. So user authentication, authorization, ensure that the queries executed by exactly authorized users, by exactly authorized entities, which entities like application level, especially with new microservices where we are dividing the components to a certain, little application. These applications has to communicate together, and sometimes the data being exposed just because of such a setup or such architecture. So this has to be tackled with a certain level of authorization and strong authentication mechanism. Use the components in the big data system that follow the same security standards. Maintain the desired level of security. So whenever you introduce a new component, consider all the access control and authentication strategy that you just implemented, or take it into account that has to be fulfilled these standards. Implement the least privileges tactics. This is widely now tactic that is used. Obviously, whenever you are giving access, make it as minimum just to perform the level of actions needed to perform the work. So that pretty much makes sense in the essence of big data. So strong and scalable encryption. This is just a little fun. This is our CEO encrypted for security purposes. Obviously, here it doesn't make sense, and it's a big deal. If it's in big data, we encrypted the data and we, let's say, lost the keys, or we scrambled the data and we are not able to access it again. That can be a really big deal. However, with new trends that like homogenic encryption that can encrypt the data while processing it and giving the same result as if it's not processed, that could be a good solution. So let's touch on scalable encryption. It's pretty important to define your encryption policy as early as possible. So we went the same with the strategy. Here's the policy. Has to be this is more emphasized. That has to be in the beginning. Why? Because in cloud systems, many of cloud systems, if you did not encrypt from the beginning, you are encountered in a big issue that you have to decommission all the data and move it from place to place and reinitiate the instances, which can be very much a big load to your backlog when considering the amount of data that you have to decrypt to move and encrypt. Second, encrypt data in transit and rest. This is no-brainer. Has to be in all situations being encrypted with appropriate system. Ensure a proper encryption key management solution. This is key element. We don't want to lose the keys. We want a good rotation. So utilizing a specific cloud provider for such a case can be valuable. Excuse me. Fourth, consider the time frame for data retention. So if you have a data that is being stored, it has to be discarded in specific time. Consider also the encryption for such a data for certain limit, and the decommissioning of this data. The database with confidentiality in mind. So keep your databases confidential as much as possible. Excuse me. So when it comes to big data monitoring and logging, so excuse me for this. Obviously, enabling logging on computational node that has to know which authorization being given, what transactions happened, as well as enabling logging on the database level. Detection and preventing of modification of logs, and regularly test and restoration of big data backups and disaster recovery plans. Privacy challenges. I recommend from my experience couple of these that is really makes sense. For example, centralizing the consent management. That's a key component to keep track of everything going on the consent. Being transparent of the data flows, regular audit, and automation, the deletion retention policies. That's really powerful in the cloud, keeping the system running by itself. Also vetted integration and advanced anonymization techniques. This is just a little joke. How much the budget can change by time. What are new trends? There's the zero trust architecture, or trust after, or trust verify and trust, the CTA, that's now in the essence of forming any new architecture. The secure access service edge, the SaaS, that is making the processing even more secure on the level of the edge, of the cloud edge, and the end component. There is the usage of AI and machine learning for threat detection. The homomorphic encryption, that encrypt the data while processing and giving the right results out of it. And the privacy enhanced technologies, decentralized identity and verification, and quantum safe cryptographic, that it's safe for the future age of quantum. Thank you for attending this session, and I hope that you enjoyed it. Please keep in touch. I was with you, Fuad Mullah, Cloud Security Architect, and you can get in touch with me on any topic related to security and in particular of big data. Thank you very much and have a good day.